Oh, hey man.
Hey man, how you doing?
How's your PhD going?
Yeah, pretty good, yeah.
Nice. I had a relativity lecture this week. It's quite confusing. Could you help me go through things? Have you got a minute?
Yeah, for sure, man. Let's go for a walk.
Sweet. So, in the question, there's two volcanoes separated in space, and they erupt at slightly different times.
Mm.
And the question's asking whether there's another reference frame where an observer may see them erupt at the same time. Where do I get started?
Okay, so let's break it down a bit. Do you know what an inertial reference frame is?
Yeah, it's like a set of objects in the same local area, right?
Okay, that's a good start point. What you said could be true when the objects are near relative to one another, but it doesn't have to be the case. The crucial part is the object's relative motion. Objects can be really far apart and still in the same frame, as long as they're traveling at the same relative motion.
Right, so you could have two spaceships on the other side of the same galaxy and they can be in the same reference frame.
Exactly, yes. There is a condition though. What can we say about the velocities of objects within the same reference frame?
Oh, God, they can't be moving. They've got to be at rest, right?
That can be true, yes. We call that a rest frame. What's important is that the object's velocities relative to one another are equal.
Oh, nice. So, if two objects are in the same frame when at rest, does that mean they're in the same frame when moving at constant velocity?
Yeah, that's it. So we should also really mention one other thing. Do you know why we always need to specify that we're working in an inertial reference frame?
Oh, yeah, it is an inertial reference frame. That means they're not accelerating, otherwise, Newton's laws aren't applicable.
Precisely. So let's take a look at our example. Let's say we have two volcanoes, A and B. Let's just focus on A for now. So we've got volcano A and two observers in the same frame as volcano A. Will the two observers agree on the time that A erupts?
I think that depends on where they are relative to Volcano A. If they are at the same distance away, then they will see it at the same time. But if they're at different distances away, then they will not agree on the time.
Have you heard of an intelligent observer?
Yeah, I think so.
Well, if you apply that to this scenario, it could help.
An intelligent observer is one that can account for signal travel time, meaning they can know when the event takes place rather than just observing it. Oh, I see. So this means one observer might receive the signal before another, but they can actually agree that it happened at one specific time.
Absolutely correct. So if we take it back to the example, will two observers in the same reference frame agree that any event happens at the same time?
Yeah, they will.
Okay, let's imagine we have volcano A and B, and we've got an observer in the rest frame in between these two. Let's say we also have an observer directly above the midpoint that's moving at 0.5 c towards B. What will both observers say about the simultaneity of the events?
Okay, so I think the stationary observer must see them at the same time, but because the moving observer is moving from A to B, they'll see B first, but because they're an intelligent observer, they'll be able to account for that velocity and agree with the stationary observer that they must happen at the same time.
You're right about the ground observer saying that the events will be simultaneous, yes. But let me give you an example as to why the moving observer won't see that. Let's say we have a reference frame moving really fast, and we've got lightning bolts that hit each side of the reference frame, A and B, and we've got an observer in the middle of that reference frame. The frame is moving towards B, so what will the observer see first?
If it's moving towards B, then they must see light from that place first.
Correct, and we know that the observer is in the midpoint of both events.
Yeah, so if it's in the midpoint and B happens first, that means in the whole frame B must have happened first, right?
Precisely. It's important to remember that simultaneity is not absolute. Just because two events are simultaneous in one frame doesn't mean that they will be in other frames. Another common thing that people get wrong is defining an event. How would you define an event?
I'd say an event is something that happens at a specific location in time and space.
Absolutely. An event has an absolute time. A common error is students thinking that the time an event relates to when an observer receives it.
Yeah, an event is defined by the emission of the signal rather than the reception of the signal by the observer.
So let's go back to the example question. We have two volcanoes, A and B, at rest in the rest frame. So A erupts a little bit before B, and we want to find if there's a reference frame in which the volcanoes erupt simultaneously. Do you know the distance in time between the two events?
The question said eruption A happens 4 milliseconds before eruption B.
Okay, so you gave a time separation in seconds, but it's easier to think of it in terms of distance. So we can do that by thinking about how far a light ray would travel in a certain time.
So the time separation would be 1,200 meters.
Yes, that's it. So we need to find a velocity in which the events are simultaneous. So what direction do you think we need to be moving?
Well, we'd be moving towards B away from A. So we're kind of moving away from the first eruption towards the second.
Yes, that's it. So what we're able to deduce about the time separations in both the rest frame and the moving frame.
So in the rest frame, we've already established that the time separation is 1,200 meters. But in the moving frame, they happen simultaneously. So that means the separation must be zero.
Correct. So to work out the speed of the frame, we know that the spatial separation is 3,000 meters, and we can plug in the values that you mentioned from before to get a velocity of 0.4 c. Has that helped to understand the question?
Yeah, thanks. Made it much better.
Nice one.
Cheers.